All right, Algebra 2, the ever long section of Chapter 3, Section 7. For each domain, state the range. That would be the y. And notice in example 3, here we are with these numbers as the domain. So for each one, I'm just going to put in. So for the y, I'm going to put in -2 minus 3. Well, that will be 5, right? Because the absolute value of -5. And I'm going to use my nifty eraser here because now I'm going to put in -1 minus 3. That will be +4. Ooh, I like this. I'm going to put in 0 minus 3. That would be 3. Thought I was erasing. Then I'm going to put in 1 minus 3, that's -2. Absolute value is 2. And last, I could put in the number 2. 2 minus 3 is -1. Absolute value is 1. So I know that when the domain are these numbers, -2, -1, 0, 1, 2, I need to show this. The range is 5, 4, 3, 2, 1. But now we're given a different thing. Now they're telling us, well, what happens when x is the set of numbers greater than 3? Let's look. What happens when I put in numbers that are greater than 3? So if I put in 4, 4 minus 3 is 1, greater than 3. 5 minus 3 is 2. 6 minus 3, you're probably seeing a pattern. But remember, numbers that are greater than 3 can also be like 3.1, 3.2. So we need to state this range as a set of all numbers where x is greater than 0. So we want to say that the set of all numbers where f of x is greater than 0. Why did I say greater than 0? Notice if I put in 3 minus 3, I get 0. What happens if I put in -1? If I put in -1, I get 4. So remember that it's never going to go into the negatives. Why? Because the definition of absolute value is the distance, which means it will be positive. All right, moving on. The same kind of questions, except now the domain is all real numbers. And we kind of just talked about this with the numbers bigger than 3. So I could put in any number here, right? Let's think about this. Can I put in 1? Yeah, because that would be a real number. Can I put in 2? All right, let's go ahead and start plugging in numbers so we're not just talking hypothetically. Can I put in 1? 1 minus 3? Yeah, that's -2. Absolute value of -2 is 2. Can I put in 2? 2 minus 3? Yep, that's the absolute value of -1, which is 1. So notice in this case the range is going to be the set of all non-negative real numbers, meaning that these numbers that come out will never be negative because of the absolute value. All right, last question for this section. Now it says to state the range and draw the graph of each function. All right, it says state the range and draw the graph of each function. So the first thing we do have to do is state the range when we're solving for this. So I'm going to state it like this. Typically the range is shown in numerical order. But let's go ahead and see what happens when I plug in the first number, -4. 8 minus 1/2 times -4. A negative becomes a positive. 2 and 4 cancel out. So this is just saying 8 plus 2, which is 10. So I know at -4, positive, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is going to be my first dot. I'm going to write the range at the end. Now if I plug in -2, 8 minus 1/2, -2, negatives cancel out, 2's cancel out, we get 9. So at -2, we're at 9. Next number. What about 0? Well, 8 minus anything times 0 is 0. Don't we just get 8? So that's going to be here. My graph is not drawn to proportion. And what if I plug in 2? 8 minus 1/2 times 2, we get 7. So 2 and 7 is here. And the last one looks like we are plugging in 4. 8 minus 1/2 of 4, we know is 2. 8 minus 2 is 6. So I know that at 4 and 6. So when I actually write my range, I want to write 6, 7, 8, 9, and 10. But notice my graph is a bunch of dots and only dots. Why don't I draw a line here? I don't draw a line because notice that each one is specified to a point. So it's just like graphing these points together.